Good day, ladies and gentlemen. Setso is back. Guys, today we are going to continue with what? The nature of roots. As for today, we are going to answer two types of questions pertaining the topic of nature of roots. The first question that we are going to answer is the following. It states for which values of k will the equation x squared plus 2kx plus 4x plus 9 is equals to 0 have equal roots. Firstly, my fellow learners, we must not forget that the general formula for the quadratic equation is as follows: y is equals to ax squared plus bx plus c. This is our general formula for what? For quadratic equation. Now we are going to take the given equation to write it in a form of a general equation. How? Like this. You are going to take your given equation, which is x squared plus 2kx plus 4x plus 9. Do you understand this one, fellow learner? Then from this point, you will then factor out your x between term 2 and term 3 to make it look like your general quadratic formula. How? As follows. You are going to write your x squared, then factor out x. Let us factor out x. Then inside the brackets, you'll be remain with what? Your 2k plus 4. Then you will then write your constant, which is 9. It equals to 0. Then now we have written this quadratic equation in a form of general quadratic formula. Do you get this point, my fellow learners? At this point, you will then do what? Identify your A, your B, as well as your C, like this. Then your A will then be what? Looking at this one, your A will be 1. Your B will then be what? Your B is any value which is next to x. In this format, your B will be the expression of 2k plus 4. Then your C, my fellow learners, will then be your 9. From this point, we'll then use what? Our discriminant equation for us to determine the value of the discriminant. Then you are going to take the discriminant formula, which is b squared minus 4ac. This is the discriminant formula. From this point, we'll then substitute your values of A, which is equals to 1, your B, which is the expression of 2k plus 4, as well as your C. Let us substitute these values where on our discriminant formula as follows. B equals the discriminant equals to open bracket, right, 2k plus 4 squared minus 4, your A is equals to 1, C is equals to 9. Then from here, let us solve or let us simplify this expression. You'll then start by expanding this one to be 2k plus 4. 2k plus 4. For this one, we are going to use our calculator. Let us use our calculator. Say negative 4 multiplied by 1 multiplied by 9. We are going to get negative 36. Negative 36. From here, you will then simplify these two brackets. Let us simplify these two brackets by multiplying 2k with 2k. We are going to get 4k squared plus this one multiplied by this one, and this one multiplied by this one. We are going to get 8k plus 4 with 2k. We're going to get 8k plus 16 minus 36. At this point, we are going to add what? Our like term, which is 8 plus 8k. 8k plus 8k. Our first like terms, let us add them. 8 plus 8, you are going to get 16. Then you write your 16k plus 16k. 16k minus, let us see, 16 minus 32. 16 minus 32 get negative 20. Now we have managed to simplify this expression to get 4k squared plus 16k minus 20. At this point, we haven't yet answered our question. Let us go back to our question. It states for which values of k will the equation have equal roots. Do you still remember the condition that we use to determine the discriminant of the nature of roots? Last time we said, let me just write on this paper. Last time we said we have different conditions that we use to determine what the nature of roots. We have these conditions whereby your delta or your discriminant is less than 0. We said such they are non-real roots. And we also had this condition whereby your delta is greater equals to 0. We said this one is real. From this point, we can clearly see that we are not going to use the non-real roots. We will then cancel this one out and try to focus on the real roots, on the real root sides. We also learned on the previous video that this delta or this side of the real root, it further branches into two. The first one was whereby your delta is greater than 0, and also whereby your delta is equals to 0. And we said this one represent unequal roots. Then we said this one represent what? The equal two equal roots. Two equal roots. This one, two an equal root. This one will represent two what? Equal roots. From this point, it is clear as well that we are not going to use this condition. Instead, we are going to take this one where our delta is equals to 0. From this point, we will then say, okay, for the roots to have, for this equation to have equal roots, we are going to use this suitable condition whereby our delta is equal to 0. We have found our delta already, which is 4k squared plus 16k minus 20. We'll then substitute the whole expression where on our delta it will then look like this: 4k squared plus 16k minus 20 is equals to 0. Do you understand? Then from this point, let us try to find the factors. To find the factors of this trinomial, we're then going to factorize what? Our trinomial. Let us try to factorize this trinomial. To make it easy, we'll then divide throughout by 2 or by 4. Let us divide throughout by 4 to make it look much simpler by saying 4 divided by 4, 16 divided by 4, 20 divided by 4, 0 divided by 4. We are going to get k squared plus 4k minus 5 equals to 0. Do you understand, my fellow learners? At this point, we'll then try to find the factors of k squared plus 4k minus 5. Let us find those factors of this trinomial by saying this is our trinomial. K squared plus 4k minus 5 equal to 0. Let us find the factors. It's so simple. You will open your bracket. After opening your bracket, and put plus this one this side and a negative this side, we're going to have k plus 5 and minus 1 is equal to 0. Let us find the root. It's so simple by using what? A zero factor theorem. We will say k plus 5 is equals to 0, or k minus 1 is equals to 0. We'll then take 5 and transpose it to the right hand side, and then becomes negative 5, or k is equals to 1. Do you understand, my fellow learners? Then yeah, this is how we solve this question of nature of roots. Thank you, fellow learners.